In this problem, we're asked to to maximize the area of a window with a semicircular top and a rectangular bottom. Okay. So one thing they tell us, the one amount of information that they give us, is that this outside perimeter, okay, so not the inside, just this outside portion there, that perimeter is equal to 20 feet, let's say. Okay. So there's a few things that we have to figure out. We are looking to maximize area. So we know the area is going to be the area of the semicircle and the area of the rectangle. Okay, so the area, let's do the area of the semicircle plus the rectangle. Okay, so the area of the semicircle, well, the area of a circle is pi r squared, so if it's a semicircle, it has to be 1/2 pi r squared. Okay. And we should label this, where here is the radius. Okay. Then the area of the rectangle will be length times width. So we'll call this width and we'll call this length. Now, there's something that we actually know here about the rectangle, and that is about the width. We know that since the width is right below the semicircle, this distance must be the same as down here. Okay. Well, since it's a semicircle, that's just the diameter, and we know the diameter of the circle is 2r. And then let's see, well, I'm sorry, just to keep our variables correct. So we'll have length and the width is 2r. Okay, so right now what we have is that the area is equal to 1/2 pi r squared plus 2r times L. Now the problem here is that we have the L. So if we could get rid of that L, then we would just have r's and we could take the derivative with respect to r and we would be on our way. So what we also now have to use is this extra information about the perimeter. If the perimeter is 20, let's see what the perimeter is. Okay, so the perimeter should be this top portion. Again, that's half of a circle, so the circumference of a circle is 2 pi r. Half of that will just be pi r. Then the other perimeter that we're looking for is this side, and that side. So that will be 2 L's plus a W. Plus 2 L's plus the W. Now, let's also do our little trick there that the W is equal to 2 R's. That'll get rid of some of our variables. So pi R plus 2L plus W is 2 radiuses. That has to be equal to 20. And now let's solve for L. So 20 minus pi R minus 2R should be equal to 2 L's. Dividing through by 2, we'll get 10 minus pi over 2r minus r is equal to L. Okay, so now this is what we're going to put into here. So let me recopy this on the next page. So the area was equal to 1/2 pi r squared plus 2RL, but we're going to substitute in the value of L, and we found L to be 10 minus pi over 2R minus R. Just double check that. Okay, all right. So now we can expand this. We have the area formula, expand by distributing. So 1/2 pi r squared, just copying that. Then I'm going to distribute all the way through. So we get 20r minus pi 20r squared minus 2r squared. 20r minus, okay. All right, lastly, let's combine some like terms here. 1/2 pi r squared minus pi r squared, so we'll have negative 1/2 pi r squared, and we'll just copy the rest. 20r minus 2r squared, and this is equal to the area. Okay, so now we can differentiate. So the derivative of the area with respect to the radius is, let's see here, using the power rule. So, excuse me, negative 1/2 pi times 2r plus 20r minus 20, just 20, minus 4r. So this should be equal to negative pi r plus 20 minus 4r. Okay. And this is what we're going to set equal to 0. Okay, so minus pi r plus 20 minus 4r is equal to 0. And so we're trying to find the critical value for r, so we need to solve for r. So 20 is equal to pi r plus 4r. And then factoring out the r, we get pi plus 4. And then dividing through by pi plus 4, r is equal to 20 divided by pi plus 4. Okay, so we put this in our calculators. 20 divided by, don't forget to open up your parentheses. Parentheses, second pi plus 4, close your, oops, I need to do that right. Pi plus 4, close your parentheses, hit enter, and r is approximately equal to 2.80. Then we can just find the other dimensions. We knew the width was equal to 2 times r, which is 2 times 2.80, and that is 5.60. And then lastly, we can find L. L was equal to, what is L? 10 minus pi over 2r minus r. 10 minus pi, oops, minus pi over 2r minus r. Okay, and we'll just use the value of 2.8 for r, so 10 minus pi over 2 times 2.8 minus another 2.8, and if we've done everything correctly, 10 minus second pi divided by 2, multiply that by 2.8, and then subtract off 2.8, and surprisingly enough, we also get 2.8 for this. So clearly the diagram that I drew was not to scale, nor is the one on the homework problem to scale.